Yeah.
All right. Seems we are live. Before we start, just want you guys to know I've never done this before, so if something goes wrong, I'm not guilty. This first meeting we had. Actually, I don't know how to pronounce your guys' names, so I would just let you guys say hi. Or I can do that later. Yeah, only one of you guys have joined, so we'll just do it later. Yeah, okay. So the idea here is to quickly talk a little bit about a Python environment that we're gonna use, which is called the Anaconda, and it's a kind of a framework. And in this framework, there's a lot of tools that you can use, including Python itself, but also some IDEs and some libraries. So it's a really nice way of starting with Python, especially to work with something related to data science. How can I capture my screen here? Screen share. All right, entire screen. Oh, something.
You need to come.
Yeah, I have to minimize, I think, right? Is it showing my screen there? Minimize it. Is it showing my screen there?
Yep.
Yep. Okay.
Yep.
So let's first start showing the website from Anaconda. Anaconda was created by this company.
Just a minute, I guess everyone has to mute. Except you, everyone has to mute.
Okay.
Yeah.
It's mute. Okay.
Okay. Once it's not on. Yeah, it's fine.
Okay. All right. So yeah, this is the website that you're gonna want to go, and the company which created the Anaconda distribution is Continuum Analytics. So this is, I just typed anaconda.org, so you can search here in their website for an Anaconda download link. It's right here on top. So Anaconda is provided free, and if I'm not mistaken, it's open source. I'm not really sure about it, but you can have it for free. There's versions for Windows and also for Mac, probably for Linux also. Yeah, here you can see Anaconda for Windows, Anaconda for OS X. So depending on your platform, you're just gonna choose which one you want. About the Python versions, we were actually talking a little bit about it. Python is it's kind of a split community, because there's a lot of people which really likes Python 2.x, and they don't, even though there's Python 3 is here for a long time, people just won't switch. So I'm not really, I'm not a long time Python developer or something. I mean, I'm really learning Python right now, so I don't have the knowledge to actually say which one's best or not. I've tried both, and I'm using mostly the 3.x kind of family. So it is working to me, but I've heard people saying things like there are some libraries that doesn't exist on 3.x, so you might have some issues depending on the kind of library that you're gonna choose to use. But to me, in my case, I mean specifically, I think both would actually work fine. I'm using mostly the newest Python 3.x, so I don't wanna say like use this one or the other one. Just choose whatever. And one thing also about Anaconda, which is really interesting, is that you can have multiple, which is so-called environments. So these environments can actually have the version of Python that you choose. So you can have an environment with Python 2 and another environment with Python 3. So you have this kind of flexibility when you are using Anaconda. It's really neat. So you can like start with this one, and then if you need the 2.x, you don't have to install it again. By using this one, you're gonna have the flexibility to install the Python 2 from it also. So I'm not gonna show. I mean, if you guys are on Windows or Mac, you know the installation from this point here is pretty self-explanatory. So you just have to download and run what the file that you had downloaded, and you have the Anaconda installed. So I'm not gonna show that because my machine already has it, already did it. So we can switch to the Anaconda window. Anaconda, when it's installed on OS X, it actually shows up as a folder. So here, Anaconda. If I open the applications, I would be able probably to find it also on Anaconda. No, it's not. I don't know where it. Yeah, whatever. So on OS X, you can just type Anaconda, and then you locate this folder. When you locate the folder, there's a launcher. So the launcher would be the one that you're gonna launch, which you could probably guess, right? And this is the main window which Anaconda provides to us. It'll take a little bit of time to load it. All right. So here we have the main software packages that you can use. So each of these you can consider like an IDE. So the IDE, I'm gonna quickly show this one on the bottom here, Spider app. I'm gonna launch it. Click on launch. This is more for you guys to have an idea of how it looks. And if you guys had worked with RStudio, it kind of resembles RStudio a little bit. So here you can create like a file and then start doing your work. I'm running Python 3.x, so if I want to do like a hello world, I had to use print parenthesis hello world. Okay. Here I have a pretty much one-line hello world code in Python that I can run, and I just hit run. It'll I have to save it first. Whatever. Okay. And here you can see here's the console. So here's where the output will go. So you see that I had the output here. Okay. And you can start playing with it. I mean, if this is your first time experiencing the Python syntax, so you're gonna wanna at least have a look at some kind of tutorial. This is not what I'm gonna show you guys today. We can do that later if you guys want also, but not today. So I mean, you can define. Let's just do something really basic here, like define a variable called variable and store some value here. This is a random string, and you can print variable, and you'll see that it will show here on my console. Okay. So this kind of environment here, the Python console, I mean, you can actually run from your terminal. And if you are using OS X, OS X already has a Python built-in, so you don't have to even install in order to do that. You can just open your terminal and hit Python, and then you have a Python environment. In my case, I'm running this one, which is from the Anaconda, but that's because I'm already installed Anaconda. So here I can do the same thing, like print something. You guys can see it working, okay? You can do some kind of basic math on it. I mean, it's a kind of console-based kind of environment. So it's similar to PHP, to some other similar script languages. So I wanted for you guys to take a look at this environment, but that's not really the main environment that we're gonna show today. What I would like to show is this one, IPython notebook. This is what I believe is a really good kind of environment to develop in Python. So let's launch this one. I'm gonna show how to. I mean, there's this easy way of launching it, just clicking here. But there's also a way of launching it directly. So here, okay, here, if you take a look at it, this is my browser. So it opened, it actually launched a web server on my own computer, and it opened the browser on a specific URL, which is this one here. You don't have to really care. I mean, I think it's always something like a localhost 2.889, something like that. So here's a tree structure, so you can go wherever you want, and like let's say you wanna create a new file. So you just kind of come here, new, and choose notebook Python. So it will open a new window and a new tab, sorry. And here is the environment that you have to run. So this is already a Python environment that you can use. And I'm gonna start by doing the same thing that I did before, a hello world. And I can come here and say run. Or more easily, I can just hit Control, return. So it will also run. And you see right underneath it the output. So what is so nice about this thing? First, it's a more comfortable way of programming because you are doing everything on your browser. Second thing, this thing that you are looking at is a file. It's a file that you can actually see on. Oh, I have to save it first. Example 1. You can see on your directory structure. Yeah. So here's the file that we are working on. So you can actually just get this file and send to whatever place you want, like to a friend through email, and he'll have everything that you have exactly as you did here. So it's really easy, really easy to share. That's one really nice thing about it. Second thing is this is a cell. So I can have as much cells as I want. So I'm going to create a new cell here, clicking plus, and you see there's a second cell here. And I can keep doing stuff that I need, like variable equals 1 times 11 times 9. Yeah. Let's run to see what happens. Oh, nothing happened. Actually, it did happen, but this thing here is not outputting anything. So if I want, let's say, to output the value of variable, I could use the same print that I used before. And now I would have the output. And if you keep doing this, you realize that it's a really easy way to keep doing small pieces of code. Like you don't have to do the whole code at one time. So it gets really easy to get used to this kind of thing because you don't have to. The more traditional way of coding is you keep increasing the file, but every time you run the whole file, right? So this is not like it works. This here actually is already running a Python kernel, and you can see if it is like doing something or not by looking at this small circle here. If it is dark, then it is because it's currently running. Like I can create a really big loop, let's say for I in range print, I'm gonna turn on really good, whatever. Let's do something like sum was equal to 1. For that, I'm gonna say sum equals 0. Yep. So this is just so we can use a little bit of CPU, so you guys can check the kernel running. So I'm gonna hit play or use control return, and if you guys see, it's blinked a little for a second here, so the kernel was running. And also, just to be sure if that actually did something or not, print the result of sum. Okay, it did work. So this is some really basic coding, you guys know, but this is just to show the idea of how to use the interface. So here you keep like creating new cells, and let's say, oh, this cell should be actually before this one. You can just come here and say, go up, and it goes up. So it's a really neat way of organizing your code. Sometimes you are doing something, and then you realize, oh, this shouldn't be here. It should be before the last thing that I was doing, or something like that. It's not that you can use functions, but each cell is not restricted to a function. So it's like a snippet. It's a piece of code that will run by itself, but that depends on the previous run code. So everything that you are looking here is a program that is running.
So it's basically the same program. So
that's the same program, right?
So you can access variables.
Yeah, I can access the same variable again here, and it will work. See? Yeah. Also, I mean, use functions. I can create a new function in Python to create a function. If you do like that, def func receives some whatever number. Then you will return the number squared. Then you call func of 9. Here you see it will return the right number. 9. Oh, it's 9 to the 9th. I don't know. Let's do 2 to the power 2. Yeah, that's easy. All right. What? Because it's 9 to the power of 9. Yeah. This double asterisk is the same thing as to the power of. I can use, like, if I want to do a square. This is not really squared. I think I said square, but it's wrong. Yeah, that's squared would be to the power of 2. Yeah. So if I do square 9, so I get 81. Yeah. And again, you can like have the same. Like I could do something like result equals 8, and I could come here in a second cell and print the results. So everything here is a program. If you do something inside a function, the scope of what you are running will keep inside the function. So that's, yeah, most programming languages are like that. So if you need to somehow access something that you did inside the function, you can use the keyword global. So it will create as a global, so you can access outside of the function. All right, so this is what I was trying to pretty much show to you guys was the interface. So we are not really doing much, I mean, code-wise. The other way that I had to start the IPython notebook, which is also called Jupyter notebook. This is actually the most recent name of it. So a lot of people still call it IPython notebooks, or even just Python notebooks, PyNotebooks. But the project was renamed to Jupyter just to make it clear that the notebooks is no longer Python only. I mean, currently you can run other languages on this kind of interface. Yeah, I didn't actually try that, but I know it is possible. You can go to the project and check that. can actually Google it quickly. Jupyter notebooks. That's probably, yeah. Yeah, here's the website for it. You can explore more about it. I didn't try anything other than Python in it. I know there's a project called Beaker Notebooks, which has built-in functional. It works with a lot of languages in the same notebook. So it's yeah. So in my case, I just explored with Python. So the secondary way that you could run the Python notebook. Oh, that's also something that you should know. This terminal here is the terminal which is running the notebook. So if I come here and try to close this terminal, so what's gonna do is that will shut down the server, so the Python notebook would stop working. So we can actually see that happening. If I go back to my web server, my web browser, see, it shows the kernel has died for some reason. I know the reason. I did it. So here you can say try to restart it. It won't work because I actually killed it. But also sometimes the kernel for some reason can fail, but not the whole IPython server. So you can try to restart and it might probably work. In this case, I won't even try to restart because it just would not work. If the IPython server stops, it will stop saving it. So remember, this whole thing here is a file. So you have to pay attention to this thing, just to be sure that you have your work saved as it should. Like here, it also auto saves. So every something minutes, it will save to you, or you can just come here and hit the save to be sure. Okay. Yeah. Oh, and the alternative way of starting the Jupyter is by coming here in the terminal and typing Jupyter notebook. So this will do the same thing as we did with Anaconda, but without needing to go there and clicking in that button. This is how I usually do, but just because I like doing it, typing. I mean, I don't know, really the best way of doing it. And I can actually show you guys some code I'm working on currently. Yeah, this is the latest file that I'm working on. So this is related to my thesis. So I'm not going to go through every single line, but just to show you guys. I mean, these are the libraries that I'm using. If you guys take a look, I'm using a lot of scikit-learns. There's also matplotlib, which I'm not really using currently, but I left it here. There's NumPy, which I use it.
What is that?
NumPy is a library to do linear algebra. Like you want to do calculus with matrices, this kind of thing. So it has a lot of built-in functions, and also, yeah, and also there's a so-called sparse representation of matrices that we use a lot, like scikit-learn use a lot, and it's a more efficient way to both to store and to process matrices which are sparse. And with text representation, we have a lot of sparse representation, because we're not gonna talk about the TF-IDF representation today, but just so you guys know, if you are converting a text file to a TF-IDF representation, you will end up with thousands of features. In other words, thousands of columns in your matrix. It's a 2D matrix, and this matrix would be really sparse. So that means that we'll have a lot of cells which just has 0 as a value, or no value. Also can be understood as no value. So this is what we call sparse representation, because it. Yeah. So this is really I don't remember if in KPT we implemented that or not, but yeah, I'm not really sure. But anyway, NumPy also implements this, and it's really good for both the storage and also the CPU work. It makes it really efficient to work on matrices. So here, like, if I wanted to run again this whole cell, I can just run it. And here, it's not really doing anything other than printing. I mean, for the output, printing libraries loaded. Just so I know, I mean, there's some. Huh?
Breakpoint? Like a breakpoint?
Yeah, like, yeah. It's more like a human interaction, you can call it. Yeah. I like to output something. Like, if you don't output anything, you might think like, oh, did it work? Didn't?
Yeah.
You know? If it didn't work, actually, it will somehow let you know. But I mean, it's like, I mean, I get used to do that for some reason. So I like doing that, always outputting something.
Yes, I could learn only for Python.
Yeah, it's Python specific. Yeah. So I don't know. I mean, internally, I don't know how they implement things because I'm not sure if you guys know, but Python is like a wrapper, so you can implement parts of Python in other languages. So Python itself, the majority of it is implemented in C, but you don't directly use it. I mean, in C language. There's also alternative representations, implementations for Python using Java, which is called JPython. So I mean, I don't know the specifics of how the scikit-learn was implemented. So it might use some alternative languages to implement, but like the user interface that it provides is for Python. There's also an interesting thing. Okay, yeah. We're just finishing. Yeah. The last thing I want to show, this is interesting. You can have cells with markups instead of code. So this cell here is actually a markup. So if I run the markup, it will actually apply the template, the styling to this cell. And you can also use, if you want, I think you can even use.
Can we share this like a file, or can we share it as a notebook?
The notebook, you can, to share it, you can. I mean, if you wanna put that online, you can run the Python notebook on a web server, which has a public IP, so it will make it available, but available to anyone. So I mean, you don't have a way of restricting it. But you can also just, I mean, if you just want to share, the easiest way is to get the file, because it's a single file. A notebook is a single file. So this file here, it exists as a file in my file system. I just get this file and share it, send through email or Dropbox, whatever. It's really, really easy to share. Yeah, let me just see if I can do some HTML here. I'm not sure. Let's say p align. Hello. No. This align still valid? Yeah. Do I have? There's a style maybe. Text align. I don't know. Oh yeah, works. Yeah. See, gets HTML also. So it's really neat. You can put images if you want. So, yeah, it's very interesting. The file that we were running before, like let's say I want to include a new cell. Hi.
Is it on?
Yeah.
Thank you.
We're about to finish, but I mean.
This is my first time, maybe I can get notes actually.
All right. We are doing a Google Hangout on there, so you can watch later if you want. Yeah. Go. Okay. Thanks, guys, for showing up. And the last thing that I'm going to show here is just to finish this video is the to do the markup.
Okay.
You just use like regular markup. Hello guys, and then you use control return to oh, I think you have to come here and change to markup, and then run, and then you have a markup. So it, I mean, makes it really stylish and easy to read through your code. Like if you take a look at this code, I have cells, really dense cells, but I use like small texts as a header to make it easier for me to even myself understand what I'm doing. You know, it really makes it easy to work. So I like this thing a lot. All right, we're gonna stop this video here. If I'm able to locate the window.
Last one.
Yeah. All right, guys. This is the end of this quick tutorial. I hope you guys have enjoyed, and I hope it worked. I don't know if it worked or not. Okay, see you.